Hello and welcome everybody to the Kreatryx YouTube channel and myself Ankit Goyal here in front of you presenting a lecture on analog electronics. So guys, soon you will be watching one of the best lectures on analog electronics, but before doing that, let me first introduce myself, my dear friends. My name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have taught more than 1 lakh students in the online and the offline classes, and presently I am working as a director at Unacademy for GATE department. But the reason, my friend, the reason up for this series is because many students were asking for analog electronics, and I had recorded analog electronics just a short while ago. But due to that huge demand, we are giving you the recorded content of the analog electronics, and you are absolutely going to love it because it will provide you an in-depth analysis of analog electronics. And that analysis will be more based on network analysis than EDC. So if you don't have a prior knowledge of EDC, that is not at all required. When I am teaching analog electronics, I will be relating it more towards the network analysis. So you need to have a good basic understanding of network analysis so that you can do well in analog electronics. And my dear friend, what I believe is after this lecture series is over, your fear of analog electronics will definitely go away, and it will seem to be one of the easiest subject ever, because you will be applying the fundamental laws and you will be finding all the answers. Okay, so it will become very easy even for an electrical engineer, because I believe electrical engineers think of analog electronics as a nightmare. They are more comfortable in machines, power system, but not in analog. But now this analog electronics course will stand you at par with the ECE engineers, and you will be able to do well in analog electronics, and I believe you can get 100% marks in analog in GATE and ESE through this course. Okay, so my dear friend, you need to watch all these videos carefully. You need to understand each and every point, and they will also have a large number of questions, so your problem solving ability will be developed. And now my dear friends, you can also join us on Unacademy Plus. With Unacademy Plus, what is the benefit if I am teaching here on YouTube itself? My dear friend, GATE rank or ESE rank is not only about the lectures. First thing you have to understand that when you come to Unacademy, the level of teaching, the level of interaction, discussion is way higher than it can ever be done on YouTube. Because there we are interacting live with the students, and you will feel that your teacher is sitting right in front of you and teaching you on a one-to-one basis. So that sort of a feeling you will get on Plus. You will feel like somebody is taking a tuition class when he is teaching on Plus. That level of personalization is there. But not only live classes, you also get recorded sessions. Whatever session you miss will be available in the recorded form. You get daily practice papers for practice. You get weekly tests to test your preparation level. You get test series, previous year question bank, short courses like crash course and rank improvement batch, and you also get doubt clearing by all the top educators. Now, when you get so many things in just one subscription, then I believe if you are serious enough to crack GATE and ESE, you can get the top rank in GATE and ESE. And you can also go for Iconic. Iconic is a superset of Plus subscription. It contains everything that is there in Plus, but many things that are there extra in Iconic, like a personal coach who will be guiding you on a one-to-one basis about the difficulties that you face, about your weaknesses, about the challenges that you might face, about the strategy part. Everything he will tell you in a one-to-one session. Then he will be seeing your test results and giving you a personalized test analysis about what are your weaknesses and how you can overcome them. Then every 2 weeks, there will be a study booster session in which you can ask your doubts, whatever problems you have, and they will be helping you clear them. That is again one-to-one. Other than that, you will also get personalized study material. Here you will get theory notes and you will get question banks. You will get interview guidance. Soon enough, interview guidance will also be added. So the student who is starting his journey right now and looking to crack GATE and ESE with the top rank, Iconic will be the best subscription for that. Stay with me till the end of the video and I'll tell you about the pricing of these subscription. And my dear friends, if you like the videos that we are putting on YouTube, we have created an entire repository at this link. bit.ly/gatelive. Here you will find all the PDFs of all the lectures and all the YouTube links. So here you will find the complete syllabus of GATE, electrical, EC and IN. You will find it arranged subject wise, chapter wise with lecture links and PDF. So this is better than any other paid course available in the market, and plus is even better than this. So you can understand, whatever everybody else is providing you paid courses, we are providing you such a course for free via YouTube. So go and visit this link and take the benefit of all the lectures that are available. Other than that, my friend, I have also created a repository of my free classes on Unacademy called as the special classes. You need to open this URL, download the Unacademy learning app, and you can attend all my free classes, live quizzes and test series. Yes, my dear friend, we are running a free test series as well. So once you download the Unacademy learning app without even paying a single rupee, you can watch all the free classes by all the top educators along with their free live quizzes. And every Sunday we are conducting a free test that also you can become a part of. And if you want to learn from me, then my entire content is available on this URL. You can just go and visit this URL and see subject by subject, chapter by chapter, whatever I have taught, that will be available on this link. So first link will provide you all the YouTube classes for free and their PDF, and the second link will provide you my special classes on Unacademy. So that much content we are providing for free. Go and watch it, and if you like it, I would suggest that you come to Plus and use the code AnkitEAC. Because my dear friend, with Ankit EAC, you will get an immediate 10% discount, as well as you will be connected to me and we can work together to get you the best GATE rank, just like I obtained in 2014 and 2018. So if you want my guidance, if you want the best guidance in this market, if you want the best educators, then you have to join Unacademy. And while joining Unacademy, apply the code AnkitEAC to get immediate discount over and above whatever Unacademy is providing. You will get 10% additional off. Okay, so now my dear friends, let's go and watch the lecture and let's learn something new that you might never ever have learned, and let's enjoy the beauty of analog electronics. And I'll meet you again after the video and I'll tell you about the plans and the pricing.
Hi guys, in the last video we discussed the basics of diode. So I told you about a PN junction diode, that when two p-type and n-type materials are combined, then we obtain a PN junction diode. I told you about the construction of such a diode, and then we saw the concept of depletion region, that is, as soon as the two materials are joined, a depletion region is formed. In this depletion region, I showed you that the electric field is taken as negative because it is from N region to P region, like this, Xn minus Xp. I told that maximum electric field occurs at the metallurgical junction X equal to 0. Then we saw that the built-in potential in a PN diode is Kt by E ln Na Nd over Ni square. We saw the built-in potential. Then we saw the operating modes of a diode. So first we talked about forward bias. In this I told you we apply positive terminal of the battery to the anode terminal and negative terminal to the cathode. And then we saw the case of reverse bias. In reverse bias I told negative terminal is connected to anode and positive to the cathode. And we derived the diode current equation. We did not derive actually, we saw the diode current equation, exponential Vd by eta Vt minus 1. I told that eta is ideality factor and Vt is thermal voltage Kt by E, which is equal to 26 millivolt at 300 Kelvin. Okay, and I told in reverse bias the diode current is constant at minus Is. For that we ignore the exponential term. In forward bias we ignore the constant term minus 1. And we saw the characteristics of the diode. The characteristics were somewhat like this. There is a knee voltage V gamma above which diode turns on the curve is exponential, and in the negative region the current is minus Is and then breakdown occurs. I told you this is the breakdown voltage minus VBR. This current is minus Is. So in this lecture we'll talk about some more practical aspects of a diode, and we'll start from the reverse breakdown. Okay. So what we know is, when the diode is forward biased, the net electric field, the direction of net electric field is from the P region to the N region. If the net electric field is from P region to N region, the holes, those are positive charge, will go from P to N, and electron are negative charge, they will go from N to P. I told you it is the flow of majority charge carriers, and since they are going from higher concentration to lower concentration, the diffusion current will dominate. Now when we saw reverse bias, in reverse bias the applied electric field was in the same direction as the internal electric field. That is why the net electric field was directed from N region to P region. That is why the holes will also go in the same direction, N to P, and electron will go from P to N. Since holes are moving from N, so in N region holes are minority carrier, so this is the flow of minority charge carrier. That means the charge carriers which are lower in concentration. If we talk about holes, in N region holes are having low concentration, in P region they are having high concentration. If charge carriers are moving from low to high concentration, it is not diffusion. Then why are they moving? They are moving due to this electric field. Hence I told you that this is an example of drift current. That means under reverse bias, minority charge carriers flow through the diode, and they are flowing due to the drift component of the current, but under forward bias they are flowing due to diffusion current. Now reverse breakdown phenomena means when reverse biasing is high, or you apply high voltage under reverse bias, then under reverse bias which charge carriers should flow? Minority charge carriers. Then there is a flood of minority charge carriers. If there is a flood of minority charge carriers, then the reverse current is very high, and that is termed as the reverse breakdown. Okay. So reverse breakdown means when we apply a high amount of voltage in the reverse biasing, then the minority charge carriers flow in large numbers. If a large current is flowing due to minority charge carriers, it is called as the reverse breakdown. Okay. Otherwise, under reverse bias, a very small current flows, which is called as reverse saturation current. That is why in reverse bias we show like this. I am only showing for reverse bias. Like the current is very small up to a certain point. Up to a certain point we break down. But if you increase the voltage above this, then the current in negative direction will increase steeply. That is called as the breakdown phenomena. Okay. Current increases steeply after a certain amount of voltage. Now there are two phenomena for breakdown: avalanche breakdown and Zener breakdown. So let us first talk about avalanche breakdown. Now this avalanche breakdown occurs for a lightly doped PN junction. Okay, it is only defined for a lightly doped p-n junction. Lightly doped p-n junction means the doping concentration should not be very high. I told you by charge neutrality. In the last lecture I told by charge neutrality you can say NaXp equal to NdXn, or you can say N into X is constant. So if the doping concentration reduces, the width must increase. We know that depletion width is equal to Xp plus Xn. So it will increase as you decrease the doping. That means in a lightly doped p-n junction, there will be a large depletion layer. Now what happens? This depletion width is always proportional to square root of VR. VR is the reverse voltage across diode. Okay. This is a relation that is derived in electronic devices, that depletion width is directly function of the reverse voltage. Now see in this manner, this is the thing that you need to know. If VR increases, if you are applying more reverse voltage across the diode, then depletion width will also increase. If this depletion width increases, the electric field will also increase. What I mean to say is, if you see a diode, okay, if we see a diode, then suppose this is a depletion layer. I told that there is an electric field directed from N region to P region. Okay. Now if you increase this depletion width, if we increase this depletion width, this electric field will also increase. Why electric field will increase? Because more charges will be present inside the depletion layer. These charges are nothing but ions. So as depletion region expands, more charges become part of depletion region, and if charge increases, electric field will also increase. Now we know electric field applies a force on a charge. The force on a charge is Q times electric field. So force on charge carrier increases. Now this charge carrier mean holes and electrons. But which ones? Because it is reverse bias, these are minority carrier. So what I mean to say is, under reverse bias what happens? Electrons go from P region to N region and holes come from N region to P region. So as you increase the reverse voltage, this internal electric field increases. If this internal electric field increases, the force on these electrons and holes will also increase. If the force on these electrons and holes increases, the velocity and kinetic energy of charge carriers also increases. Okay, their velocity and kinetic energy will increase. If the velocity and kinetic energy increases, then what happens? Suppose this electron is going at high velocity. It strikes a negative ion. Negative ion means it has an extra electron. Okay. When it strikes this atom, due to kinetic energy, it will release the electron. One is the original electron, this one is the original. And what will be left again? what will be left is negative ion with a hole. That means we have created one hole and one electron. So what we can say, when this electron strikes the atom, one hole and one electron is created. Okay, are you getting my point? So where does it strike? Basically it strikes within the depletion layer. So again I am repeating in order for you to better understand. How I started is, when we apply large reverse voltage, I told when the reverse voltage increases, then two things are happening. One is the depletion width is increasing, other one is the electric field is also increasing. This electric field increases the force on the charge, force on hole and force on electron. They also increase. If this force increases, the velocity by which they are moving or their kinetic energy increases. And when electron strikes negative ion, electron and hole are produced. How a hole is produced? I told you this negative ion is nothing but an acceptor impurity which has accepted an electron from the donor atom. It has taken an electron, that means it has one additional electron. Now when this electron will strike the atom, that extra electron will leave the atom, and if it leaves the atom we have one free electron. If it leaves the atom we have one free electron, and the vacancy left by electron will be called as a hole. Okay, one free electron is generated and the vacancy left behind will be called as hole. So electron and hole are produced. Now this electron and hole will now contribute to minority carrier current. I told you that under reverse bias the current is contributed by minority charge carriers. So if you are producing more charge carriers, the current through the diode will increase. Now this electron produced, see, there was one electron that struck an atom. One electron is produced, one is the original electron. This electron will strike another atom. It will produce one electron, one original electron. This will again strike an atom. One electron and one original electron. So see, initially there was one electron, in the next stage it were 2, then 4. So number of electron will keep on increasing, due to which the diode current will also increase, and this is called as avalanche breakdown. Okay, avalanche is a condition in which the concentration is multiplying. So here concentration is multiplying every time by 2. In the next stage we will have 8 electrons. So are you getting my point? That in avalanche breakdown what happens? In avalanche breakdown, with reverse voltage increase, the force on the charge carriers increases. This force increases their kinetic energy, and when they strike atom, then it produces more electrons and holes, and current further increases. Now see what happens. This kinetic energy also depends on the mean free path of electron. Why mean free path? See, when electron is moving, when electron is going forward, it is experiencing a force. So the longer it travels, the more it accelerates. Think about it. We say V equal to U plus AT. That is the equation of motion. So if you increase time, the velocity increases. That means if electron travels for longer time, then its velocity will be higher. Okay, its velocity will be higher if it travels for longer distance. Now think like this. If you increase temperature, if we increase temperature, then vibration of atoms will increase. These atoms will start vibrating about their own position. If vibration increases, then collision increases. If collision increases, the time for which electron travels reduces. Think of it like this. Suppose I am traveling in a market. I am walking in a market. If the marketplace is too crowded, I will collide more number of time with other people. If market is not very crowded, then I can freely travel. So if atoms start to vibrate, then what happens? Then collision will increase and electron will not be able to travel much. If it is not going to travel much, its velocity will reduce. Velocity reduction means kinetic energy will also reduce. If kinetic energy reduces, then this phenomena cannot be sustained, which means if you want to sustain this phenomena, you have to further increase the voltage. Means with increase in temperature, there are less chances that the breakdown will occur, and hence in order to have breakdown, you have to further increase the voltage. That is why what we say is, in avalanche breakdown, it has positive temperature coefficient. What is meant by positive temperature coefficient? That as temperature increases, the breakdown voltage increases. Increase in breakdown voltage means you have to apply more voltage to cause breakdown. Are you getting my point? As temperature is increasing, kinetic energy of electron is reducing. If kinetic energy of electron is reducing, it may not be able to eject an electron from the atom. If it is not able to eject an electron from the atom, this breakdown will not happen. So if you want kinetic energy to increase again, you will have to apply more voltage. So positive temperature coefficient implies that with increase in temperature, you have to apply more voltage to cause breakdown. Okay. So what you have to remember in avalanche breakdown now? That avalanche breakdown occurs when electrons strike the other atom to produce electron hole pair, and it has positive temperature coefficient, which means with increase in temperature you have to apply more voltage to cause breakdown. Now let us move to the other method. The other method is called as Zener breakdown. Now in Zener breakdown, what happens? First of all, it occurs in highly doped p-n junction. In highly doped p-n junction, as I told you, that n into x is constant. So if you increase doping, this x will reduce, or what we can say, that depletion width reduces. Now if the depletion width reduces, or the depletion layer is very thin, if the depletion layer is very thin, suppose like this. Generally, for Zener breakdown to happen, we need a highly doped p-n junction, and this depletion layer should only be up to 1 or 2 atom thick. Okay, it should not be more than this, 1 or 2 atom thick. That means the depletion layer is very thin. It should have a thin depletion layer. In previous case, there was lightly doped p-n junction, so the depletion layer was very wide. Now, since the doping is high, the electric field is also high. If this electric field is high, then holes in this region will cross over to the other side, and electron in this region Electron in which region? P region. Holes in N region. That means I am talking about which type of carriers? Minority carrier. Electron on the left hand side will travel to the right hand side. So this process is called as tunneling. Tunneling means they are directly passing through a barrier. Passing through a barrier without crossing the barrier. Think of it like this. Suppose there is a wall in front of you. If you want to cross the wall, either you climb the wall and then cross it. The other method could be if you directly pass through the wall. So this tunneling is the second option, that is when the charge carriers directly pass through a barrier without actually crossing that energy barrier. So this is called as tunneling, and as electric field increases, this tunneling increases and the diode current also increases. This phenomena is called as Zener breakdown. Now the voltage required for Zener breakdown is less than voltage required for avalanche breakdown. Okay, that is mainly due to highly doped and the lightly doped junction. In highly doped junction, less voltage can cause breakdown. In lightly doped junction, you have to apply more voltage to cause breakdown. Now for Zener breakdown, what we need to do is, for Zener breakdown, think like this. Electrons lying in the valence band have to be promoted to conduction band. Okay, that is when electron go from valence to conduction band, it means electrons are becoming free electrons. Are you getting my point? Electrons are usually bound to the atom. This negative ion is what? This is basically a boron atom with an extra electron. So this electron is bound to the nucleus of boron. So it is called as a bound electron. So if you want to make it free, you have to promote it from valence band to conduction band. I told you in the band theory itself that freeing an electron means promoting it from valence band to conduction band. For that, it has to pass through the energy gap. This energy gap reduces as temperature increases. Okay, that means electrons can easily become free. If electrons can easily become free, then breakdown is easy. If breakdown is easy, it means it has negative temperature coefficient. What is meant by negative temperature coefficient here? That if you want the breakdown to occur, you can apply less voltage if you increase the temperature. In avalanche breakdown, what did I tell you? If you want the breakdown to occur at higher temperature, you will need higher voltage. In Zener breakdown, if you want breakdown to occur at higher temperature, you will need lower voltage. So that is the difference between Zener breakdown and avalanche breakdown. Also remember, avalanche breakdown occurs in lightly doped p-n junction, Zener breakdown in highly doped p-n junction. So these are two phenomena by which there is reverse breakdown in a diode. Now let us talk about the capacitance of a diode. See, if you see the depletion layer, it has positive and negative charge. If there is positive and negative charge, then that means it is acting as a capacitor. So we can find out capacitance of a diode. Now what is the reason why I am trying to find the capacitance? It is because I want to represent diode by a circuit, and a circuit is drawn in terms of resistance, inductance and capacitance. So if I figure out the capacitance, then I can draw the equivalent circuit of a diode. So there are two capacitances defined for a diode. When the diode is forward bias, we have diffusion capacitance, and when the diode is reverse bias, we have junction capacitance. So first I will talk about this second term, that is junction capacitance. Now think like this. When a diode is reverse bias, its depletion width will be high. In forward bias, depletion width is low. In reverse bias, depletion width is high. Like this, there will be depletion width in a diode. Okay, here we will have positive ions. This will be called as your depletion width. Now, if you increase the reverse voltage, as I told you in the breakdown itself, if we increase the reverse voltage, the depletion width increases. Now, if you plot the charge concentration on both the sides, this is X equal to 0 metallurgical junction. On the right hand side, we have N-type material. On the left hand side, we have P-type material. Now see, N-type material will have doping concentration Nd. P-type material will have doping concentration Na. On the N side, we have positive ions. We have positive ions and the concentration is Nd. This is Xn. On the P side, we have negative ions and their concentration is Na. So I will show by negative sign, minus Na, minus Xp. Now if you increase the reverse voltage, the depletion width should increase. So by increasing the voltage by an amount delta V, if I say VR increases by delta VR, then there will be change in the depletion layer. Depletion layer will increase on both the sides. If depletion layer increases on both the sides like this, if depletion layer increases on both the sides, then the charge inside the depletion layer will also increase. Now see, more number of ions are there. So VR increases by delta VR, depletion width increases and the charge inside the depletion layer also increases. So this junction capacitance is nothing but it is d delta Q depletion by delta VR, or you can write down dQ by dVR, that is your junction capacitance. It always comes proportional to VR to the power minus half and it has the units of picofarad. It is in the range of picofarad. Are you getting my point? When you increase the reverse bias voltage, the charge inside the depletion layer increases and charge per unit voltage will give me the junction capacitance. Okay, but it is only in reverse bias. Now when we talk about diffusion capacitance, see, a diffusion capacitance is taken under forward bias. Now what happens? Initially suppose there is no biasing. When there is no biasing, there is depletion layer in the diode. Even if there is no biasing, there is depletion layer in the diode. As I told in the previous video, there is an internal electric field like this. This is under the case of no bias. Now if you apply forward bias, if we apply forward bias, like this I am showing. If we close this switch, that means we are applying forward bias because we are connecting positive terminal of the battery to the P region and negative terminal to the N region. Here we have holes and here we have electron. So this battery will cause a electric field from P towards N region. This will be the electric field applied by the battery. This will cause holes to move from P to N, and electrons will move from N to P. Okay. So when sudden forward bias is applied, the charge carriers cross from one region to the other. So if this is the depletion region, like this, these are negative ions, these are positive ions. So holes are crossing to the N side, so holes will come here. Electrons are crossing to the P side, so electrons will come here. This will appear as positive charge, this will appear as negative charge. So suddenly a charge appears, holes on the N side and electrons on the P side. Okay. So this I will call as charging of capacitor. Okay. Now this is N side. N side, already electrons are there. This is P side, already holes are there. Now these electrons will move into the P side and these holes will move into the N side. First they have just crossed the depletion layer and now they will move in their respective regions. What I mean to say is, suppose holes have entered the N side, that is called as charging. Now holes will diffuse through to the N side. What I mean to say is, actually, if we talk about the charge concentration, in the N side electrons are majority and in the P side electrons are minority, and their concentration is Ni square by Na. On the N side holes are minority and on the P side holes are majority. This green represents holes and red represents electrons. Now as I told you, holes are crossing to the N side. So here holes are coming and electrons are crossing to the P side, electrons are coming. That means suddenly hole concentration on the N side increases. That is, hole concentration on N side increases and electron concentration on P side increases. Now due to diffusion, they will move from higher concentration to lower concentration like this. This process is basically diffusion, and this I will call as discharging of capacitor. So what I mean to say is, when holes and electrons cross over to the other side, I am considering it as the charging of capacitor, and then they are diffusing through the region, I am calling it as discharging of the capacitor. So the diffusion capacitance, also called as storage capacitance, is written as ID, that is diode current, tau naught by 2 Vt. ID is diode current. This formula is actually important. ID is diode current. Tau naught is basically called as lifetime of charge carrier. We are not going into much detail in this. And Vt is your thermal voltage. Okay, Vt is your thermal voltage, that is Kt by E. And this capacitance is in the range of nanofarad. Okay. So this you have to remember, the formula for diffusion capacitance. So what is diffusion capacitance? When we forward bias a diode, the charge carriers enter to the other region, and when they diffuse through the region, we call it as discharging of capacitor. So let me summarize what we have learnt in this video. I first told you about the reverse breakdown phenomena. I told you that reverse breakdown occurs when the reverse voltage is high. The first phenomena in this was avalanche breakdown. I told you it occurs for lightly doped junction. Secondly, it has positive temperature coefficient. Then we talked about Zener breakdown. Zener breakdown occurs due to tunneling. It occurs only for highly doped junction and it has negative temperature coefficient. Then we talked about junction capacitance, that is under reverse bias. I told you junction capacitance is directly proportional to VR to the power minus half. Then we talked about diffusion capacitance, that is in forward bias. It is also called as storage capacitance, ID tau naught by 2Vt. Okay. So storage capacitance is due to crossing of the charge carriers from one side to the other. Junction capacitance is due to increment in the depletion width by applying reverse voltage. Okay. In this entire video, the only formula you have to remember is this one. And you can remember these 2 points about the avalanche and the Zener breakdown. This will be all from this lecture and I will continue in the next one.
Hello everybody, how did you like the lecture? Did you like it or not? Did you enjoy the concepts or not? Tell me in the chat and the comment section. Did you guys like what you just saw? Did you guys understand each and everything, my dear friends? Okay, so if you liked it, then please share, please like the video and please leave a comment behind because your comments are very valuable to all of us and we do read your each and every comment and we go through them to understand what are the difficulties you are facing and how we are performing on YouTube. And my dear friend, a bonanza for you. Every subject is available on this YouTube channel. You just need to scroll through the channel and you will find all the courses. EDC, EMT, COM, machine, power system, power electronics, network, signal, control, digital, maths, APT, everything is available here, everything. So you can just use this channel as your entire preparatory study material. Okay. Other than that, now all of you who wanted to know about the pricing of Plus, 1 year subscription on Plus will cost you 27,225 if you apply the code Ankit ESE. But now my dear friend, there is a new subscription, 18-month subscription. Those of you who are starting your preparation mid-year can target GATE twice or you can target GATE and ESE mains with 1.5 year subscription. That will cost you 34,650 if you apply the code Ankit ESE. If you see the difference, only 7,000 difference is there, but you are getting 6 months extra. And even better, you can go for 2 year. It will cost you 39,600. That is again in just 5,000 rupees, you are getting 6 months extra. So you can target all the exams like GATE, ESE, semester exams, ISRO, BARC, everything you can target with just one subscription. And if you go for Iconic, in which I told you about the personal coach, study material, interview guidance, for 12 months it will cost 4,500 if you use the code Ankit ESE, and for 24 months it will cost you 54,000 if you use the code Ankit ESE. Ankit ESE is your code, my code, our code, and that will give you an instant 10% discount over and above whatever Unacademy is offering you. And my dear friend, that will connect you to me so that we can work together towards getting the best GATE rank. So don't hesitate, join today because winners always start early, winners never start late. So it's always better to start immediately rather than thinking about it and becoming late and later on regretting your decision. Believe me, you will not even regret one day when you join Plus. So it's high time that you join Unacademy Plus and get the best out of you and become the best version of yourself. And my dear friend, this is the Telegram channel for our YouTube team. You will find all the lecture updates here. And this is my personal Telegram channel. If you wish to get in touch with me with my personal Telegram channel, GATE AIR1. Okay, GATE AIR1 is my Telegram channel. You can get connected to me. You will get notes, you will get lecture links, everything you will get here. All the new initiatives information will be provided here. These are the other channels that we are running in other than Kreatryx. You will find electrical junction. Here you will find short videos for gate preparation, gate question for PYQ, GS terminal for non-technical content of SSC and RRB, Pathshala to learn engineering through animation, SSC JE for your JE and AE exams, my dear friends. Other than that, Telugu, if you want to learn engineering or gate and ESC preparation in the Telugu language, if you are comfortable with it, go for Telugu. Other than that, we have separate channel for mechanical, civil, computer science. You will find all these channels. Please share these channels with your friends as well, so that they can also get benefited in the same manner that you are getting benefit from our side. Okay. So thank you everybody. See you soon in the next video. Don't forget to like, share and subscribe. Share it among your college friends, among your Facebook, WhatsApp, Telegram, Instagram, everywhere you need to share it. And you need to subscribe to this channel, press that red button and hit the bell icon, because my dear friend, this channel is creating a revolution in the gate and ESC industry, and you, my friend, are a part of this revolution. So see you soon. Thank you.